But why do stars do that? What's happening way up there, or more accurately down here, that makes them sparkle like cosmic glitter? Hello there, and welcome to the Sleepy Teacher, where curiosity gets comfy and bedtime stories come with a touch of stardust and science. I'm so glad you're here tonight. We're going to take a gentle journey through the night sky, tracing the soft shimmer of stars and answering a question as old as stargazing itself. Why do stars twinkle? Now, I do hope this video helps you unwind and drift gently off to sleep, but fair warning, it might get just interesting enough to keep your brain quietly buzzing. If that happens, well, at least you'll be lying awake learning something fascinating. Not a bad trade, really. Before we begin, I'd love it if you could tap that like button. It helps more sleepy minds find their way here. Maybe even subscribe if you haven't already. I'd also be delighted to know where in the world you're watching from and what time it is there. Feel free to share in the comments below. Are you just climbing into bed, or has the night already wrapped itself around your home like a soft, quiet blanket? Wherever you are, and whatever time it may be, let's get cozy, relax, and gaze up together. The stars have been waiting. Let's begin with a question you've probably asked yourself at least once while staring up at the night sky. Why do stars twinkle? You've seen it. A star flickering gently in the black canvas above, winking and shimmering like it knows a secret. It's beautiful, mysterious, and oddly soothing. But why do stars do that? What's happening way up there, or more accurately, down here, that makes them sparkle like cosmic glitter? Well, the first thing to know is that stars don't actually twinkle. Not really. If you were to float above Earth's atmosphere, out in the quiet vastness of space, stars would appear as steady points of light, no flickering, no shimmering, just calm, unblinking dots of distant fire. So, if stars themselves are stable beacons, the twinkling must be happening somewhere between them and us. And it is. The culprit is the thin, invisible blanket of gases wrapped around our planet, Earth's atmosphere. You see, starlight travels a very long way. We're talking trillions of miles. It crosses the cold, silent void of space without so much as a wobble. But then, in the final tiny stretch of its journey, just the last 100 kilometers or so, it hits our atmosphere, and suddenly things get a little chaotic. The Earth's atmosphere is not a still, uniform shell. It's more like a shifting ocean of air, constantly moving and changing. It's full of different temperature layers, varying densities, pockets of moisture, and gusts of wind. Think of it as a giant transparent lava lamp, beautiful but not exactly stable. As the starlight passes through this ever-moving air, it gets bent. This bending of light is called refraction. You've seen this before, like when a straw looks like it's bending in a glass of water. That same principle applies here, except with a billion times more complexity. Now imagine starlight passing through layer after layer of air, each with a slightly different temperature and density. The light bends slightly in one direction, then another. It jiggles, it wobbles, it doesn't travel in a straight line anymore. And by the time it reaches your eyes, it appears to be dancing ever so slightly, twinkling. This effect has a name: stellar scintillation. It's a beautiful phrase, isn't it? Like something from a poem, but it's pure science. The name for the shimmering of stars caused by the atmospheric turbulence between them and us. Interestingly, not all stars twinkle the same way. Some seem to pulse brightly, others shimmer softly, and a few don't seem to twinkle much at all. That's partly due to their position in the sky. Stars closer to the horizon twinkle more dramatically than those overhead. Why? Because when you're looking near the horizon, starlight has to pass through more atmosphere, thicker layers of air, more turbulence, more distortion. It's like trying to spot something across a steaming hot road versus looking straight up into a clear sky. The stars directly above you have the most direct path to your eyes. They don't have to wrestle with nearly as much air, so they twinkle less. Still, even at their steadiest, there's usually a gentle shimmer to them, a subtle flicker, like a candle far across the room. Now here's something interesting. Planets don't twinkle like stars do. If you've ever looked up and spotted a bright star that seems unusually steady, chances are you are actually looking at a planet, maybe Venus or Jupiter. Planets shine with a calm, unwavering light. Why? It all comes down to size, or rather apparent size. Stars are so far away that they appear to us as infinitesimally small points of light. All their brightness is packed into a single sharp dot. So when the atmosphere shifts that dot, even a little, you see a twinkle. But planets, being much closer to Earth, appear as tiny disks in the sky, still small, yes, but not point-sized. So even when the atmosphere distorts the light coming from a planet, the effect is averaged out across its wider shape. The flickering cancels itself out. The result? A calm, steady glow like a flashlight through a foggy window instead of a pinprick laser through smoke. Of course, this wasn't always understood. For most of human history, people saw twinkling stars as something magical, even alive. Some cultures believed they were ancestors watching from above, their eyes glinting in approval or judgment. Others imagined they were lanterns lit by gods, trembling in the night wind. The word twinkle itself feels whimsical, doesn't it? It's a soft, lyrical word. It dances off the tongue. That's probably why it found its way into lullabies and nursery rhymes. Twinkle, twinkle, little star being the most famous, a simple question from a child's song that even adults find strangely profound. But beneath that childlike wonder is a world of physics and atmospheric science, quietly humming away every night. It's the same starlight that guided sailors across oceans, inspired poets and astronomers, and helped early civilizations mark the passage of time. And all the while it twinkled more because of Earth than the stars themselves. One more little twist. Stars don't all emit the same kind of light. They have different temperatures, and that means different colors. Hotter stars shine blue or white. Cooler stars shine red or orange. Sometimes when the atmosphere gets especially unstable, say on a hot summer night, you might notice stars flickering with flashes of different colors. That's the atmosphere playing tricks with wavelengths. It's a bit like looking through a prism that's constantly wobbling. You're seeing momentary glimmers of starlight separated into its colors before snapping back together again. So the next time you look up at a twinkling star, remember this. It's not just a distant sun dancing for your amusement. It's a message from the cosmos, one that's traveled across millions of years and unimaginable distances only to get its final polish from the air above your head. It's a mix of cosmic elegance and earthly chaos, light that began its journey before humans learned to farm, flickering now because of a breeze you can't even feel. Isn't that strangely comforting? So let your thoughts float up there with the stars for a while. They'll shimmer and flicker for you, just as they've done for every soul who ever looked up and wondered. If the stars themselves are steady, then what's really making them twinkle? It's the journey their light takes through Earth's atmosphere. And that atmosphere, oh, it's a busy, bustling place even when it looks calm. It may seem invisible and still from down here on the ground, but in reality it's a constantly shifting ocean of gases, always swirling and stirring. To understand why the sky above us shimmers the way it does, we need to take a slow, peaceful dive into the layers of air that wrap around our world. Let's start with a soft descent, or perhaps more accurately, a gentle ascent. The atmosphere is made up of several distinct layers, like a giant cosmic cake. From the surface of the Earth upward, these layers are the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Each one plays a role in shaping the journey of starlight, but the one that makes the biggest difference, the one responsible for most of the twinkling, is the troposphere. The troposphere is the layer of atmosphere closest to the Earth. It stretches from the ground up to about 6 to 10 miles high, depending on where you are. If you have ever flown in an airplane, you've spent time in the upper parts of the troposphere, sipping tomato juice and hoping your luggage didn't end up in a different time zone. This layer contains most of the air we breathe, and nearly all of the weather we experience: clouds, winds, rain, snow, turbulence, and those slightly judgmental seagulls at the beach. The troposphere is like a planetary mixing bowl. It's full of temperature differences, moving air currents, and little whirlpools of heat and moisture. And when light from a star passes through this churning soup of air, it bends. Sometimes it bends just a little, sometimes a lot, but either way it bends, and that makes the star appear to jiggle or flicker. Now let's talk about refraction, but gently. Refraction is what happens when light changes speed as it moves from one substance to another, say from the vacuum of space into the dense air of Earth. Light travels fastest in a vacuum, slower in air, and even slower in water or glass. That change in speed causes the light to bend. You've seen this before, probably without realizing it. If you've ever dipped a spoon into a glass of water and noticed it looked like it snapped in half at the surface, you've witnessed refraction. Or maybe you've stared at the wavy lines rising from hot pavement on a summer day. Same thing. That shimmer, that ripple, that's light being bent by the heat-distorted air. In the atmosphere, refraction happens all the time. But the atmosphere isn't a single sheet of uniform air. It's made of countless little patches, each with its own temperature, pressure, or heat and moisture content. These differences create pockets where the air is slightly more or less dense, and starlight gets bent every time it passes through one. Think of it like this. Imagine you're looking at the stars through a calm swimming pool. If the water's still, you see the stars clearly. But now imagine someone doing cannonballs nearby. Every splash, every ripple changes the way the water moves. The stars begin to shimmer, stretch, and wiggle. The atmosphere does the same, only with less splashing and fewer inflatable flamingos. Now, while the troposphere does most of the heavy lifting when it comes to twinkling, the higher layers contribute too. The stratosphere, which sits just above the troposphere, is calmer and less turbulent, but it still has temperature gradients that can affect the path of starlight. The mesosphere, above that, where meteors burn up, adds a final sprinkle of refraction, especially for stars near the horizon. The higher up you go, the thinner and colder the air becomes, but even these faint, icy layers can wiggle the light just enough to add to the twinkling effect. It's a bit like adding extra layers of frosted glass over a lamp. Each one adds a new flicker, a new shimmer, until the final glow reaches your eye with that familiar, comforting sparkle. Now an important detail. The way the atmosphere bends light doesn't just cause twinkling. It can also shift the apparent position of stars slightly. If you were to track a star's location over time, without correcting for atmospheric effects, you'd find that it dances in tiny, unpredictable patterns. Astronomers have known this for centuries. That's why serious stargazing, especially the scientific kind, involves all sorts of clever tricks to see through the atmosphere. But before we get to telescopes and space observatories, let's return to the poetic side of this dance, because in a way, Earth's atmosphere turns every clear night into a kind of living light show. Without it, stars would shine with perfect steadiness. Beautiful, yes, but perhaps lacking that little touch of magic. There's something quite charming about the fact that the stars twinkle, not because of what they are, but because of where we are. It's a very human phenomenon. Twinkling. It exists only from our point of view, shaped by the air we breathe and the world we inhabit. It's a reminder that even as we gaze out into the cosmos, our experience of the universe is filtered through the lens of home. And here's a curious little fact. Not all twinkling is created equal. On some nights, the stars seem to glitter wildly. On others, they hardly twinkle at all. That's because atmospheric conditions vary constantly. Calm, still air, like on a cold winter night, reduces turbulence and makes the stars appear steadier. On a hot summer evening with rising warm air and gusts of wind, the twinkling can be especially lively. In fact, experienced stargazers and astronomers often rate the seeing conditions of the night sky based on how much the stars are twinkling. Less twinkle usually means better conditions for telescopic observation. But for the casual dreamer lying on a blanket, a little extra shimmer never hurt anyone. So the next time you look up and see a star flicker gently in the dark, remember the invisible ballet happening above you. The layers of our atmosphere, so often taken for granted, are in constant, graceful motion. They bend the light from ancient stars, sculpting it into a delicate dance just for your eyes. It's as if the sky is breathing in-out, each breath shifting the starlight just enough to make it sparkle. And all of this, every twinkle, every flicker, is made possible by air. the same air that carries the scent of rain, the rustle of trees, and the quiet hush of night. It's not just a medium we move through, it's an artist painting the stars with emotion and life. And here you are, wrapped in that same air, watching the sky do what it's done for billions of years, twinkle just for you. Let's imagine something rather beautiful for a moment. Somewhere out there, unimaginably far from Earth, a star is burning, steady, relentless, ancient. It may be older than our planet, older than our sun, older than the very concept of time as we understand it. And from that star, a single particle of light, a photon, is released. It begins a journey, not just any journey, but one that will span vast cosmic distances and billions of years. Also, it can one day flicker in your eye for the briefest of moments. That's the story we're following now, the life of a photon from star to sky to you. Photons are tiny packets of light. They have no mass. They travel at the speed of, well, light. And once they're set in motion, they don't slow down, veer off course, or get tired. They are the ultimate long-distance travelers, and they begin their journey deep inside the roaring heart of a star. Take a star like our sun, for instance. Deep within its core, nuclear fusion is constantly turning hydrogen into helium, releasing enormous amounts of energy in the process. Some of that energy becomes heat, some becomes radiation, and some becomes photons, little messengers of light that have to fight their way to the surface. And when I say fight, I mean really fight. A photon born in the core of a star might bounce around inside that star for tens of thousands, even hundreds of thousands of years. It doesn't move in a straight line. Instead, it gets absorbed and remitted by atoms over and over again, zigzagging like a moth at a disco until it finally escapes the star's surface and breaks free into space. Once free, the photon begins what might be the smoothest part of its journey, coasting through the near-perfect vacuum of space. Out here, there's very little to get in the way. No atmosphere, no clouds, no turbulence, just emptiness, darkness, and the occasional planet or dust cloud. A photon can travel for millions, even billions of years without colliding with a single thing. That means the light you're seeing from some stars tonight began its voyage long before the first humans walked the Earth. Let's pause on that for a moment. If you're looking at a star that's, say, 100 light years away, the light from that star began its journey around the year 1924, back when people were still driving Model T Fords and jazz was just hitting its stride. That photon was already en route. And now, tonight, it finally arrives, only to get knocked around in our atmosphere and made to twinkle, a dramatic finish for a very patient traveler. Now, space isn't completely empty. Along its path, a photon might pass through clouds of cosmic dust, magnetic fields, or gravitational distortions caused by massive objects like black holes or galaxies. These encounters can bend the photon's path, slow it slightly, or scatter it. But for the most part, space is generous and lets light pass freely. Some photons do get diverted or absorbed, of course. That's why not all starlight reaches us. Some never make it past distant gas clouds, others are captured by planets or swallowed by the void. But for the few that do find their way here, the final stretch of their journey is the most treacherous of all, our atmosphere. We talked about how the atmosphere bends and distorts light in the last chapter, but let's look at it now from the photon's point of view. After sailing serenely through the vacuum of space, our photon now hits a swirling sea of molecules. It enters the atmosphere and whoosh, it's like trying to run a straight line through a crowded room of dancing people. The photon gets jostled, nudged again, its path bending slightly this way, then that. The result, when it finally hits your eye, is a little wobble in its apparent position, a twinkle. And speaking of hitting your eye, let's not gloss over how amazing that is. Your eye is made up of millions of light-sensitive cells, and in perfect darkness it's sensitive enough to detect even a single photon. Yes, just one. If your surroundings are dark enough and your eyes are fully adjusted, you might actually see the impact of one lonely particle of light that's traveled across space for millennia just to say hello. And when that happens, your brain interprets the signal as light from a star that to you has always been there, always twinkling. But really what you're seeing is a brief interaction between a particle and a person, a handshake across the cosmos. It's easy to forget sometimes that starlight is not just a glow in the distance, it's a physical thing. It's matterless but not meaningless. Every flicker you see is a story, a fusion of survival, of time and distance. It's like the star is whispering something to you, and the universe is bent over backward to deliver the message. In astronomy, there's a term for this kind of journey, the light path. It describes the route that photons take from a celestial object to our instruments or to our eyes. Understanding the light path is crucial because it helps astronomers determine how much of what they see is due to the object itself, and how much is due to the distortions along the way. In a way, when you're looking at the stars, you're not seeing the present, you're looking into the past. The farther away a star is, the older its light is by the time it reaches you. That means the sky is a kind of living time machine. Every star is a snapshot of what it looked like years, decades, centuries, even eons ago. And yet we experience that light now in this moment. It's a curious paradox, light from the past illuminating the present. You, lying there gazing at the stars, are participating in an ancient ritual. People have done this for tens of thousands of years, long before the science of photons or the word twinkle ever existed. And while the language and understanding may have changed, the feeling hasn't. The awe, the stillness, the sense of wonder, they've stayed the same. So the next time you spot a twinkling star, pause for a second and consider what you're really seeing. You're witnessing a photon's final destination. After a lifetime spent racing across space, dodging dust and gravity, it ends its journey not in a telescope, not in a lab, but in your eye. It's a gentle reminder that the universe is vast, ancient and wild, but it's also personal. You're not just an observer, you're part of the story. You, lying there with your thoughts, are the final chapter in a photon's cosmic journey. And if that doesn't make you feel both tiny and cherished, I don't know what will. If you've ever looked up at the night sky and noticed that not everything twinkles, you're not imagining things. In fact, you may have already stumbled upon one of astronomy's easiest observational tests: how to tell the difference between a star and a planet. Here's the secret. Stars twinkle, planets don't, or at least not nearly as much. That soft flickering starlight, the kind that seems to shimmer like a candle in the dark, is something stars do best. But those bright, steady lights that hang calmly in the sky, those are often planets. And they glow with a quiet certainty, like they're just a little bit more grounded even though they're floating in space. But why the difference? After all, both stars and planets are shining points of light in the night sky. Right. Well, yes and no. Let's start with the stars. Stars are incredibly far away. Even the closest one beyond our Sun, Proxima Centauri, is over 4 light-years from Earth. That's roughly 25 trillion miles, which is an awful lot of zeros. Because of this vast distance, stars appear to us as infinitesimally small pinpricks of light. Not dots, not disks, just a single shimmering point. That's important, because when a point of light travels through Earth's atmosphere, it's highly vulnerable to all the atmospheric refraction we've been talking about. Each little patch of moving air can bend that tiny light path just enough to make it jump ever so slightly in the sky. To your eyes, that movement appears as a twinkle, a little flicker or flash as the light shifts position or intensity. Now let's turn to the planets. While stars are burning giants, trillions of miles away, planets in our night sky are part of our own solar system. They're relatively close, at least on a cosmic scale. Venus, for example, can come as close as 25 million miles. That's still not exactly next door, but compared to a distant star, it's practically a neighbor borrowing sugar. Because planets are so much closer, they don't appear to us as pinpoints. They may still look tiny, but under magnification, or even just from the way their light behaves, they're actually small disks of light. And here's the key: when light comes from a disk instead of a point, it's more stable. Why? Because even when bits of the light from a planet are bent by the atmosphere, the distortions tend to cancel each other out. One edge of the disk might get bent one way, another edge might go slightly the other way, and the overall effect is a kind of visual averaging. The result? The planet doesn't flicker, it just glows. Imagine this. You're looking through a wavy piece of glass at a candle flame. The flame, being small and sharp, will dance and shift dramatically as the glass distorts the image. But now imagine looking at a larger glowing light bulb through that same glass. The light bulb still gets distorted, but the overall image remains much steadier. That's the difference between how we see stars and how we see planets. And here's something fun. Once you know this trick, you can go outside on a clear night and put it to the test. Find the brightest star in the sky. Is it flickering, flashing slightly red and blue at the edges, dancing like it's had too much coffee? Probably a star. But if it's glowing with a serene, unwavering light, chances are you've found a planet. Venus is the classic example, often called the evening star or morning star. It's the third brightest object in our sky, after the sun and moon. But unlike real stars, it shines with a smooth, creamy glow. Jupiter and Saturn too are often visible to the naked eye and stand out for their steady presence. They don't twinkle, they assert themselves quietly. Now, there are exceptions to the rule. Planets can twinkle, but it's rare, and usually only happens when they're very low on the horizon. That's because when a celestial object is near the horizon, the light has to travel through a much thicker slice of atmosphere to reach your eyes. Think of it like trying to see something through a very long, slightly murky tunnel. The thicker the atmosphere, the more distortion. So even a disc-shaped object like a planet can start to flicker a little. Still, in most cases the difference is obvious. Planets sit steady while stars sparkle. This difference hasn't just helped backyard astronomers, it's helped professional ones too. Long before telescopes existed, early sky watchers learned to distinguish stars from planets just by paying attention to how they behaved. In ancient times, planets were known as wandering stars because, they moved across the sky relative to the fixed stars. They had their own path, their own slow dance, and then crucially they didn't twinkle like the others. Even the ancient Greeks noticed. The philosopher Ptolemy noted that stars had a flickering nature while planets did not. And over time this difference helped astronomers map the heavens, track celestial movements, and ultimately understand our place in the solar system. So the next time someone asks how to tell a planet from a star, you can just smile and say, look for the one that isn't twinkling. But the story doesn't end there. You see, twinkling, or the lack thereof, is more than just a visual oddity. It's a reminder that everything we see in the sky is shaped by both what it is and how we're looking at it. The atmosphere, the distance, the angle, the type of object, all these factors come together to create what we experience as the night sky, and that's part of what makes it so endlessly fascinating. The sky isn't a static painting, it's alive, moving, changing, revealing just a little more to anyone willing to stop and look. Planets with their calm glow might not dazzle in quite the same way as their twinkling cousins, but they're no less magical. In fact, once you start noticing them, it's hard not to feel a quiet sort of connection. That point of light that's not a distant star in another galaxy. It's a world, a place, a real physical body orbiting our sun, lit not from within but from the reflection of our shared star's light. Some of those planets have moons, some have storms, some have rings, and some just maybe have mysteries we haven't even imagined yet. So while the stars may twinkle and steal your attention with their glittering charm, don't overlook the planets. Their calm, steady presence is a different kind of wonder, one that whispers instead of sings. And as you lie back and look up, letting your eyes wander across that cosmic sea, try to spot the ones that hold still, the ones that don't flicker but just are. They're not stars, they're neighbors, and in the grand silence of the night, they're keeping you company. Long before we had telescopes, satellites, and space probes, long before anyone knew what a photon was or what the atmosphere even did, humans were watching the stars. Night after night, they gazed up at those twinkling lights and wondered what they were, why they moved, and what their strange shimmering dance could possibly mean. And when we don't yet have science to explain something, we do what humans do best. We tell stories. Every culture on Earth has looked to the stars and spun tales around them. Some imagined them as gods, others as spirits, ancestors, animals, or omens. The way stars twinkled, flickering, changing color, vanishing and reappearing, only added to their mystery. To the people of ancient times, this wasn't just the result of warm air and light refraction, it was magic or divine will, or maybe a message from beyond. In ancient Greece, for example, stars were often associated with the gods of Mount Olympus. The shimmering of the stars was said to be the gods playing in the heavens, or the light of divine chariots racing across the sky. One particularly bright star might be considered a hero placed in the sky by Zeus himself. The flickering, perhaps that was the hero winking at his descendants. The Greeks also told the tale of Orion the hunter, who was placed in the stars after his death. When his constellation twinkled brightly in the winter sky, it was said to be him hunting once more, his bow drawn in the shimmering darkness. Meanwhile, in Aboriginal Australian mythology, some of the oldest continuous cultural traditions on the planet, twinkling stars were often interpreted as signs from ancestral spirits. Different communities had different stories. Some believed that the shimmering stars were campfires of ancestors burning far off in the sky. Others saw twinkling as a way for the spirits to communicate with the living, offering guidance, reassurance, or sometimes warnings. One story from the Yolngu people of northern Australia describes how the stars are part of the dream time, the foundational mythological past when ancestral beings created the world. When stars twinkle rapidly, it's seen as the spirits becoming more active, watching over the people on Earth and keeping an eye on their actions. In ancient Japan, the story of Orihime and Hikoboshi explains two bright stars, Vega and Altair, that shine across the Milky Way. According to legend, the two were lovers separated by a heavenly river, only allowed to meet once a year. On that night, if the stars twinkled brightly, it was believed the lovers were especially happy to see each other. If clouds blocked the sky, they cried, and their tears became the rain. Even the Norse, with their mythology rich in giants, gods, and cosmic wolves, had tales of the stars. They believed the sky was a great dome made of the skull of a giant, and the stars were holes through which the light of the celestial fires shone. The flickering of stars, perhaps those fires burning, crackling softly behind the curtain of night. In Central and South America, the Maya and Inca peoples were keen observers of the stars. They built temples aligned with celestial events, tracked planetary movements, and used the twinkling of certain stars to predict weather patterns. In some traditions, a rapidly flickering star was thought to foretell a coming storm or drought. The sky wasn't just a canvas of stories, it was a living calendar, a warning system, a spiritual map. Of course, not all myths were friendly. In some cultures, a twinkling star might be an ill omen. It could be the eye of a watchful spirit, or a warning of war or death. The unpredictable nature of twinkling, how a star might suddenly flare or fade, was unsettling as much as it was beautiful. In parts of West Africa, some communities believed that stars were the spirits of unborn children or the recently departed. Their flickering was interpreted as a kind of communication, a whisper from another realm. The brighter the twinkle, the stronger the spirit. It was a comforting thought that the dead were not gone, just shining above, still keeping watch. And we can't forget the famous North Star, Polaris. It doesn't twinkle nearly as much as other stars, especially when it's high in the sky, which gave it a reputation for steadiness that made it a powerful symbol across many cultures. To ancient navigators, it was a guide. To spiritual leaders, it was a sign of constancy in a changing world. The fact that it didn't twinkle much was part of its mystique. It was like the one star that kept its cool while all the others danced. Even in more recent times, twinkling stars have continued to inspire art, music, and poetry. From the classic lullaby Twinkle, Twinkle, Little Star to Van Gogh's swirling masterpiece, The Starry Night, we've never stopped being enchanted by those flickering lights above us. And that's what makes twinkling so special. It's not just a side effect of atmosphere. It's a bridge between science and story, between the observable and the imagined. Even now, when we know exactly why stars twinkle, there's still something magical about it. Knowing the physics doesn't take away the poetry. it adds to it. It tells us that our ancestors weren't wrong to see mystery in the stars. They were just looking with a different kind of eye, one that blended observation with wonder, facts with feeling. And as you lay there now, perhaps on the edge of sleep, you are doing the same, blending the quiet science with the deep and ancient wonder of the sky. But what if we could get closer to the stars? What if we could escape the atmosphere and see them as they truly are, steady and serene? What would that tell us? It turns out, that's exactly what astronomers did, and what they found when they peered beyond our atmospheric veil is a story even more beautiful than the twinkling we see from home. A story of cosmic vision and the power of a quiet perspective. For centuries, astronomers were limited by a simple but frustrating fact. Their view of the universe was filtered through Earth's turbulent atmosphere. It was a problem they called seeing, and it was the enemy of sharp images. The twinkling that is so charming to the naked eye is a nightmare for a scientist trying to photograph a distant galaxy. The constantly shifting air blurs everything. It's like trying to read a book while the page is rippling in the wind. Early solutions to this problem involve building telescopes in high, dry places like mountaintops, where the air is thinner and more stable. These mountaintop observatories, like those in Chile and Hawaii, are still among the most powerful on Earth. But even at these great heights, some atmospheric distortion remains. The ultimate solution, a long-held dream for generations of astronomers, was to get above the atmosphere entirely. This dream became a reality with the launch of the Hubble Space Telescope in 1990. Orbiting high above our planet, Hubble could finally see the universe with a clarity that was impossible from the ground. With no air to cause twinkling, no atmospheric gases to block certain wavelengths of light, and no weather to obscure its view, Hubble could capture stunningly clear images of stars, galaxies, and nebulae. When a star is observed through Hubble, there is no shimmer, no flicker, no poetic dance. It appears as a perfect, steady point of light, just as it would if you were floating in the silent vacuum of space yourself. This wasn't just a prettier picture, it was a revolution in astronomy. By eliminating the atmospheric distortion, Hubble allowed scientists to make precise measurements and see details they had never been able to before. It has since given us some of the most iconic images of our cosmos, from the pillars of creation to the deepest ever views of distant galaxies. Of course, Hubble was just the beginning. In 2021, the James Webb Space Telescope was launched, taking this concept a massive step further. Unlike Hubble, which orbits relatively close to Earth, Webb is located about 1 million miles away, far beyond the reach of Earth's heat and light. This distant and frigid location allows it to observe the universe in infrared light, which is crucial for seeing through thick clouds of cosmic dust and for peering back in time to the very first galaxies. The James Webb Space Telescope doesn't see twinkling light because it's not looking through our atmosphere at all. Instead, it's operating in a completely pristine cosmic environment, capturing the universe's quietest and most ancient secrets with perfect clarity. But just because these space telescopes offer a more truthful view of the stars doesn't mean the twinkling we see from Earth is any less meaningful. In a way, the twinkling is the universe's way of reminding us of our place in it. It's the grand, sweeping cosmic journey of a single photon, culminating in a beautiful, chaotic interaction with the very air we breathe. It's the silent dialogue between a star that has been shining for 1 billion years in the ever-changing atmosphere of our own small planet. The twinkle is a uniquely earthly experience, a local phenomenon that connects us to the universal. So as you lie in bed tonight, don't feel cheated that the stars you see aren't as steady as the ones in a NASA photograph. Instead, cherish the twinkle. It's a testament to the long, incredible journey of light, and it's a small, beautiful piece of cosmic theater put on just for you, right here on Earth. The distant cosmos may be vast and unchanging, but our experience of it is personal, intimate, and constantly alive. And that is a story worth listening to. As you drift off to sleep, we've explored how the twinkling of a star is really a story about Earth, a narrative of our atmosphere's constant motion. But what about the star itself? When we look past the earthly effects, what is the story a star is telling us? It is one of immense scale, unimaginable power, and a lifespan that stretches beyond our comprehension. The light that travels for millions of years to reach us carries within it an entire cosmic biography, encoded in its color, its brightness, and its subtle shifts. Consider the color of a star. We saw earlier that the atmosphere can sometimes create a colorful flicker, a momentary glimpse through a wobbling prism. But a star's true color is a fundamental property. A star's color is a direct indicator of its surface temperature. The cooler stars, like our Sun, which is a comfortable yellow-white, are on the warmer side of the spectrum, but not nearly as hot as some others. The truly hot stars, those with surface temperatures soaring into the tens of thousands of degrees, burn with a fierce blue or white light. On the other end of the scale, cooler, older stars, sometimes called red giants, have a gentle, warm glow, a soft orange or even a deep red. When you look at the night sky, you are seeing a celestial tapestry of different temperatures and ages. The bright red giant, Betelgeuse in the constellation Orion, for instance, is a massive star nearing the end of its life, while the brilliant blue-white Rigel, its neighbor, is a much younger and hotter star. The colors of the stars are a silent language, a clue to their age, size, and ultimate destiny, a story told in shades of light. And what about a star's brightness? To us, some stars appear brighter than others, but this isn't always a simple measure of their true luminosity. A star's apparent brightness depends on two things: how much light it's actually giving off, its intrinsic luminosity, and how far away it is from us. A star that is incredibly luminous but very far away might appear dimmer in our sky than a much less luminous star that is our cosmic next-door neighbor. Think of it like two light bulbs. A small dim light bulb up close can look brighter than a huge powerful one that is a mile away. Astronomers have developed clever ways to account for this. By studying a star's color and other properties, they can estimate its intrinsic brightness. By comparing that to how bright it appears from Earth, they can then calculate the star's distance. This is how we know that some of the stars that appear dim to us are actually colossal beacons of light, so far away that their brilliance is muted by the sheer scale of the cosmos. The twinkle, the color, the brightness, all of these are layers of information carried on the same beam of light, and each layer tells a different part of a star's story. The twinkle is the final earthly flourish on its journey. The color and brightness are the deeper truths about its life and its place in the universe. This brings us back to the silent, steady light we see from space telescopes. By removing the distortion of the atmosphere, we're not just getting a clearer image, we're allowing the star to tell its story without interruption. The crisp, clean image of a star through a telescope like Hubble or Webb is not a sterile or less magical view, it is a more profound one. It's a look at the star as it truly is, a direct connection to that ancient fiery heart, unfiltered and pure. This pure view allows astronomers to do more than just measure distances. It allows them to witness the birth and death of stars, to see the subtle pulsations of variable stars, and to watch as the light from an exploding supernova illuminates a nebula millions of light years away. In these moments, the star's own story becomes part of the universe's grand narrative, and we, through the steady eye of our orbiting telescopes, are privileged witnesses. So while we on Earth will always cherish the twinkling stars, the knowledge that beyond our atmosphere they are telling a far deeper, more intricate story, adds another layer to that bedtime wonder. The next time you look up, let your mind travel past the shimmer, past the veil of Earth's air, and imagine that steady, unblinking light, carrying its ancient story to you. And that story, that steady, unwavering light, continues to reveal more of itself as we expand our vision. It's a story that is not just about a single star, but about how all the stars are connected to each other and to us. That is the story we will turn to next. The beautiful chaos of stars in motion. In fact, let's take a moment to consider that idea of the star's story. Think of our own lives. We have our beginnings, our vibrant youth, our long, steady middle ages, and our eventual peaceful ends. A star's life is much the same, just on a scale we can't fully grasp. A star is born from a cloud of gas and dust, a cosmic nursery known as a nebula. In this nebula, gravity pulls the gas and dust together, growing denser and hotter until finally it ignites into a star. For a star like our Sun, this main sequence phase will last for billions of years, a long and stable existence, fueled by the slow burning of hydrogen. It's in this long, quiet middle chapter that our Sun has warmed our planet and allowed life to flourish. But all things must change. Eventually, a star will run out of its main fuel source. For a star like our Sun, it will expand into a red giant, swelling to an immense size. It's a kind of cosmic exhale, a deep sigh at the end of a long life. But for much bigger stars, the end is far more dramatic. They will collapse in on themselves and then explode in a brilliant flash called a supernova, for a brief time outshining an entire galaxy. It is a stunning, beautiful and violent end, but it is also a beginning. The debris from a supernova, the heavy elements like iron and gold, are scattered throughout space, becoming the building blocks for new stars, new planets and new life. In a very real way, we are all made of stardust. Our bodies contain the atoms forged in the heart of stars long dead, the iron in your blood, the calcium in your bones, the carbon in your cells. All of it was once part of a star's fiery life and its dramatic death. So when you gaze up at the night sky and see that steady, ancient light from a distant star, you are looking at a sun, the star in its own unique stage of life, in its own unique moment in time. Perhaps you are seeing a newborn star, still glowing brightly from its fiery birth. Or maybe it's a massive blue giant, living its short, brilliant life. Or even a faint red dwarf, a tiny star that will burn quietly for trillions of years. The possibilities are as endless as the stars themselves. Each point of light is a different story, a different chapter in the great cosmic book. And all of this information, all of this profound and intricate detail, would be forever lost to us if we only saw the universe through the gentle but distorting haze of our atmosphere. The twinkling is beautiful, yes, but it is also a kind of cosmic white noise, a blurring of the true signal. By getting above that noise with our space-based instruments, we've not only clarified our view, but we've opened up a much deeper conversation with the cosmos. We've moved from simply being observers of the twinkling lights to being active readers of the stars' secret diaries, and those diaries tell us not only about the stars but also about ourselves, our origins, our connection to everything. And as we continue our gentle journey into the night, we'll explore how this profound connection goes even further. The stars aren't just isolated points of light, they are part of larger groups and systems bound together by the invisible, powerful force of gravity. In fact, most stars are part of a larger family, a swirling dance of cosmic bodies. So let's turn our attention now to the great congregations of the night sky and the unseen bonds that hold the universe together. To truly understand a star's story, we must see it not as a solitary figure, but as a member of a great cosmic family, bound together by the fundamental force of gravity. It is gravity that sculpts the night sky, pulling stars into pairs, clusters, and the sprawling spiral arms of galaxies. While a star's individual twinkle is a dance with our atmosphere, its larger movements are part of a slow, stately ballet choreographed by gravity across eons. Think of our own solar system. The Sun, a single star, holds a family of planets, moons, and asteroids in a tight gravitational embrace. Each body is in constant motion, orbiting the Sun in a predictable, elegant rhythm. But our Sun is not alone in the universe. In fact, it is relatively unusual for a star to be as solitary as ours appears to be. Astronomers estimate that more than half of all stars in our galaxy are part of a binary star system, or even a multiple star system, where 2, 3, or more stars are locked in a gravitational dance, orbiting each other. Imagine 2 suns, or even 3 or 4, each with its own planets, all orbiting a shared center of mass. This isn't science fiction. It's a common reality throughout our galaxy. The twinkling you see from one of these stars might actually be the combined light of 2 or more stars, their light paths jostling and bending through our atmosphere in unison. For a long time, the only way to detect these binary systems was to notice the light from one star periodically being eclipsed by its partner. Now, with more advanced telescopes, we can resolve them as separate points of light, watching their beautiful, slow orbits. But the dance of gravity doesn't stop at binary stars. Gravity pulls stars together into much larger groups known as star clusters. There are two main types of these clusters. The first are globular clusters, which are ancient dense spheres of hundreds of thousands, or even millions of stars. They look like sparkling celestial beehives, held together by an incredible gravitational pull. The stars within them are ancient, often among the oldest in the universe, and they are packed so tightly that from the perspective of a planet within one, the night sky would be a brilliant tapestry of light, with thousands of suns visible at all times. The twinkling from a globular cluster, as seen from Earth, is a chaotic, collective shimmer, the light from countless stars being bent and distorted all at once. The second type of cluster is an open cluster. These are younger, less dense groups of stars, often still located within the molecular cloud from which they were born. Think of them as cosmic youth hostels, where stars hang out together for a few 100 million years before gravity and their own velocities scatter them across the galaxy. The famous Pleiades, or the Seven Sisters, is a beautiful example of an open cluster, a small group of shimmering stars in our winter sky that seem to float together. And finally, gravity is the force that binds billions of stars along with gas, dust, and dark matter into the massive cosmic structures we call galaxies. Our Sun, along with all the stars we see in the night sky, are part of the Milky Way galaxy. It is a vast spiral-shaped collection of over 100 billion stars, all orbiting a supermassive black hole at its center. Our solar system is located in one of the Milky Way's spiral arms, and as we orbit the galactic center, we pass through different regions, sometimes through denser clouds of gas and dust. This grand galactic motion, while far too slow for us to perceive in a human lifetime, is a fundamental part of our cosmic reality. The twinkling of a star, therefore, is not just the dance of its light through our atmosphere. It's the light of a star that is part of a binary system, in a star cluster, all swirling within the great spiral of the Milky Way. And as we look out into the night, we are not just seeing light from the past, we are seeing the light of countless gravitational dances, all happening at once. So when you gaze up at the night sky and you notice a particularly bright star that seems to shimmer and wink, remember that you are a witness to a symphony of cosmic motion. The twinkling is the final, intimate note of that symphony, played just for you by the air above your head. But the true music is the slow, powerful, and eternal dance of gravity, holding it all together in a beautiful and silent embrace. The stars are not alone, and neither are we. We are all part of this magnificent cosmic ballet. As you drift off to sleep, you can let your mind imagine that gentle gravitational tug, the quiet pull that keeps everything in its place. And that thought is in its own way the most comforting bedtime story of all. A story of a universe that, despite its immense size and chaos, is held together by an unseen force. What would it be like to see that force in action, to observe the very structure of the cosmos? That is the journey we will begin now, with a soft look at the invisible architecture of our universe. We have spoken of gravity, the grand choreographer of the cosmic ballet, a silent, powerful force that holds stars in their orbits and galaxies in their form. But what does this invisible architecture actually look like? We can't see gravity, but we can see its effects: the graceful curves of a galaxy's spiral arms, the tight sphere of a star cluster, the slow, stately dance of planets around a star. It is through these visible signs that we begin to sketch the unseen map of the universe. The cosmos is not a random scattering of stars and galaxies. It is a network, a web, a great tapestry woven by gravity on a scale that is truly breathtaking. Imagine for a moment that the universe is not just the black canvas you see at night, but a three-dimensional field full of hills and valleys. A massive object like a star or a galaxy creates a dip or a well in this field, and smaller objects, like planets or other stars, roll down into that well, trapped in its gravitational pull. This idea was first proposed by Albert Einstein with his theory of general relativity, which describes gravity not as a force but as a curvature of space-time itself. It's a beautiful thought, that the universe is not just empty space but a fabric, a kind of trampoline, and the stars and planets are the weights that bend its shape. This warping of space-time is a fundamental part of the star's story that we've been following, not just in its birth and death, but in the journey of its light. Even the light from a star can be bent by the gravity of a massive object it passes by, a phenomenon known as gravitational lensing. We see this happening when the light from a very distant galaxy is bent and magnified by a closer galaxy cluster, creating a distorted and beautiful arc of light. It's as if the distant galaxy is winking at us, not because of our atmosphere, but because of the gravity of another galaxy, a cosmic wink from a place we can barely imagine. This gravitational architecture also helps us understand why we see the sky we do. When you look out into the night, you see the stars of our own galaxy, the Milky Way, but you can also catch glimpses of other galaxies like Andromeda, the large spiral galaxy that is our nearest major neighbor. It's a diffuse smudge of light, a faint glow that has traveled for over 2 million years to reach us. But it too is part of this gravitational tapestry. The Milky Way and Andromeda are on a collision course, a slow and majestic dance that will take billions of years. They are two great cosmic islands slowly drawing closer to one another, held together by the invisible threads of their mutual gravitational attraction. We won't be here to see the final collision, but we can see the beginning of their journey every time we look at the Andromeda galaxy. And on an even larger scale, galaxies themselves are not randomly scattered. They are arranged in vast structures called galaxy clusters and superclusters. Think of it like this. If a star is a person, then a star cluster is a village, and a galaxy is a city. A galaxy cluster is a country, and a supercluster is an entire continent. These massive cosmic continents are separated by vast cosmic voids, and all of them are held together by the unseen web of gravity and dark matter. Dark matter is a mysterious substance that we can't see, we can't touch, we can't even directly detect, but we know it's there because of its powerful gravitational influence. It's the ghost in the machine, the invisible scaffolding upon which the visible universe is built. It's what holds galaxies together, preventing them from flying apart. Without dark matter, the galaxies would simply unravel, their stars spinning out into the cosmic void. So in a way, the twinkling of a star, the beautiful shimmer we see every night, is also a testament to this unseen, unnameable substance, the quiet and mysterious architect of the universe itself. So as you lie there with the thought of twinkling stars in your mind, I want you to expand that thought even further. Imagine the star's light traveling for millions of years, not just through empty space but through this cosmic web of gravitational hills and valleys, through the invisible scaffolding of dark matter, through the slow-motion dance of galaxies. It's a journey that is guided not just by the light's own speed, but by the very structure of the universe itself. The twinkling, the last little bend in the light's path, is just the final note in a symphony of gravitational interactions, a journey that began with a star's birth and ends with the quiet stillness of your own mind. There's something deeply comforting about this idea, that even in the vastness of space, there is an underlying order, a hidden structure, that holds it all together. The universe is not a chaotic mess, it is a beautifully designed, incredibly complex and constantly evolving tapestry. And every single point of light you see, every single twinkling star, is a thread in that tapestry, a story waiting to be told. And as we prepare to drift a little deeper into this thought, we'll explore what it means for us not just as observers but as participants in this great cosmic drama. The light from a star, a story of its life and its place in the universe, is not just a one-way message, it's a conversation, a slow and patient dialogue between the distant cosmos and us. The question is, what are the stars trying to tell us, and what have we learned by simply paying attention? That is the soft query we will ask of the night sky next, a query that begins not with a telescope, but with a quiet mind and a deep breath. For our earliest ancestors, the stars were not just points of light, they were a grand cosmic clock, a calendar painted on the night sky. The slow and stately procession of constellations across the seasons told them when to plant their crops, when to hunt, when to prepare for the coming winter. The twinkling of a star near the horizon at dawn was not just a flicker of light. It was a sign, an omen, a celestial bell tolling the arrival of a new season. This wasn't science as we know it today, but it was a deep and meaningful connection, a trusting relationship between our planet's rhythm and the rhythm of the stars above. We learned to survive, to flourish, by listening to the silent wisdom of the sky. The fact that the stars twinkled and danced and that certain planets held their light steady became a part of this ancient knowledge, a subtle distinction in the great book of the heavens. It was a conversation written in light and read with patience and careful observation. But as our tools became more sophisticated, our listening grew more acute and the conversation deepened. We began to realize that the light from a star held not just information about its position, but about its motion, about where it was going and where it had been. This led to one of the most beautiful and surprising discoveries in all of science, the Doppler effect as it applies to light. You have probably experienced the Doppler effect in your everyday life. You hear it when an ambulance or a train passes by. As the sound source approaches you, the pitch of its siren or horn seems to get higher, and as it moves away, the pitch drops. The sound waves are being compressed as the source moves toward you, and stretched out as it moves away. Our ears interpret this change in wavelength as a change in pitch. While the exact same principle applies to light, as a star or a galaxy moves toward us, its light waves are compressed, shifting them toward the blue end of the color spectrum, a phenomenon we call blue shift. And as a star or a galaxy moves away from us, its light waves are stretched out, shifting them toward the red end of the spectrum, a phenomenon we call redshift. This isn't the colorful twinkling that our atmosphere causes. It's a fundamental property of the light itself, a clear and unmistakable signal of motion, a direct answer to the question, are you coming or are you going? This simple observation was, and remains, one of the most profound conversations we've had with the cosmos. It allowed us to measure the speed and direction of stars that were light years away, to map the great gravitational dance we spoke of earlier, and to begin to sketch the true nature of our galactic neighborhood. But the real revelation came when astronomers began to apply this knowledge to other galaxies, not just the stars within our own. They discovered something truly astonishing. The vast majority of galaxies we could observe were redshifted, not blue-shifted, and the farther away a galaxy was, the more its light was redshifted. This meant that almost everything in the universe was moving away from everything else, and doing so at an incredible speed, and that the universe itself was expanding. It was a discovery that changed everything. It gave us our first glimpse into the origin story of the universe itself, a journey that began with a moment of rapid expansion, the Big Bang. The starlight that you see, that beautiful twinkling light, is not just a light from a single star's past. It is a ghost echo of the entire universe's beginning, a whisper from a moment so ancient that our minds can barely form the thought. The light itself has been stretched and pulled, along with the expanding fabric of space, turning a brilliant flash of blue light into the faint, distant glow of red, a cosmic sigh that tells us of our universe's great and continuing growth. So, when you see that twinkle tonight, let your mind feel the layers of its story. It is first a story of our own atmosphere, a beautiful little dance. It is then a story of a star's life and its place in a grand gravitational ballet, a story written in color and light. And it is also, now that you know, a story of the universe's great expansion, of its slow and majestic journey through time. It is a conversation that has been happening for billions of years, and you right now in this quiet moment are a part of it. There is a sense of wonder in this thought, that the stars are not just there to be seen, they are there to be understood, to be listened to. And the more we listen, the more we realize that the stories they tell are not just about them, but about us, about our origins, our place, our potential. The light from a star is a precious message, one that has traveled unimaginable distances and has passed through the ages, only to arrive now in this moment to be received by you. But what about the light that doesn't travel so far? What about the light that is closer to home? The light of our own solar system, the planets, the moons, the objects that reflect the gentle warmth of our own sun. The light from these objects, which does not twinkle, has its own stories to tell. Stories of neighboring worlds and celestial companions. That's a whole other kind of quiet conversation. And that is where we will go next, a journey from the distant, ancient twinkling stars to the serene and steady lights of home. Ancient twinkling of a star, a dance between light and our own atmosphere. We then ventured past that shimmer to see the star's own story, written in its color and motion, a conversation about its birth, life and death. We saw the universe's grand architecture, held together by the unseen force of gravity and dark matter, and we learned how the light from distant galaxies carries the profound tale of an expanding universe. We then turned our gaze inward to our cosmic neighborhood, appreciating the calm, steady glow of planets, a story of proximity and shared sunlight. And now, our journey brings us to its final destination, to the planet beneath us, to the very spot where we are lying. It's a journey that completes the circle, bringing us back to the most important part of the story, our home. From a cosmic perspective, our planet is a single beautiful world, just another object orbiting the sun. Yet for us, it is everything. And this world too is a story written in light. Every single thing on this planet is, in a very real way, made of the light from a star. The warmth on your skin, the energy that powers your body, the food that nourishes you, all of it comes from the sun. The light from our star is captured by the green plants of our world through a process called photosynthesis, and that energy is passed on through every living thing. We are, in our own small way, children of the sun, animated by the light that began its journey from our star's fiery heart. And as we have seen with stars and planets, our world also has its own kind of light, its own kind of twinkle. Look at the photo of Earth at night from space. You see the flickering, scattered lights of cities, a human-made shimmer that marks our presence on this cosmic stage. They are our own little fires, our own constellation of existence. We also have our own natural lights, the green and purple glow of the aurora borealis, as our atmosphere dances with solar winds, a beautiful silent conversation between our planet and the sun. So the next time you look at the stars and wonder at their gentle flicker, remember the full circle of this story. It's not just a story about them out there in the quiet dark. It is also a story about us, right here on a planet made of stardust and powered by sunlight. The light from a star travels a cosmic journey to reach us, gets its final little chaotic dance in our atmosphere, and then it is absorbed by our planet, becoming a part of the world and a part of us. The twinkling of a star, then, is more than a simple optical effect. It is a profound cosmic whisper that tells us we are connected to the distant past and the vast universe, connected to the light of our neighboring planets and the warmth of our own sun, and connected to the very ground beneath us. There is a deep peace in this thought, the feeling that you are not just a person lying on a bed in the dark, but a part of a great unified story. The cosmos is not something separate from you. You are part of it, a crucial chapter in its long, beautiful book. And in that calm, reassuring thought, you can now rest. You can close your eyes knowing that your own light is a part of the greater cosmic light, and in that knowledge there is perfect peace. Now, as the night deepens, let your mind become quiet. Breathe in the silence. Breathe out your thoughts. Feel the gentle warmth of your bed, the stillness of the room, and the quiet comfort of the world as it turns. The stars will continue to twinkle for you, and the planets will continue their steady glow,